Do anything weird? Oh, you're doing something weird. I'm not sure why Past Jeff decided to do this, but oh well. I don't have an example with. Well, I'm not going to say. I'll give it too much away. What's your answer on part B?
Z-star.
Say again?
Z-star.
Why?
Because it has population.
Yes, sigma is known. What's more important than that?
That is greater than
Yeah, n equals what was it?
41.
41. Greater than 30. Jeff. Why do I have not to do NP and Q? Well, I don't have any P's and Q's. This is a meaning problem. That's when n greater. If I have P's and Q's, they want to get involved. So it's a one-tail test. Alpha is point, where'd it go? It's right here, yeah, 0.5. We can use z-scores. You guys find the appropriate z-score for this. 0.05, one tail, z-score. Anybody?
1.65.
Almost. I don't think he said so. What side of the chart is that? What side of the picture is that on? Isn't it down there? So the z-score should be positive or negative. Yeah, so again, t-score chart, we made it one page. It just tells me the number. We're the humans. We can see what side it's on, so we know if it's negative or positive. You guys understand that? You know it's going to be negative. It's down there. You know it's negative. But it always trips people up when they put the wrong sign on this thing. So negative 1.645. So if z star, good Lord, Jeff, is less than negative 1.645, what can we do?
Reject
Huh?
5. Reject 5.
Good. So that's called the rejection region, because if you get into it, you can reject the null. That makes sense. Reject the null, support the high. This, by the way, is one statement. If I say the first dude is wrong, I also at the same time am saying it looks like the other dude is right. Does that make sense? So if I fail to reject, I automatically fail to support the other guy. Those go together. Okay. So let's see. What do we know from the sample? N is 41. What's X bar? 13.7. What's sigma?
5.04.
5.04. So what's the new sigma?
178.71.
So 5.04 divided by square root of 41, right? Sigma over square root of n. Well, what did you say that was? I'm sorry.
0.7871.
787.
1. Yeah.
Okay. I like it. So yeah, you can use more decimal places than that. That's beautiful, but at least 3. So go ahead and do the z star. Figure it out. We got everything we need. Figure out what z star is. Z star is our data minus the supposed middle divided by the a new standard deviation. So what do you guys get for that?
-305.
Yeah, I get negative 3.05. Do we make it far enough away? We had to be this far away. Do we make it far enough away? Where would negative 305 be in this picture? Would it be in here or up here?
Down below, right?
Yeah, it's gonna be less than this, so it's gonna be way down here. So, did we make it in the rejection region?
Yeah.
Hell yeah, we're way this shit in there. Right, we're way in there. Stay with me now.
Yes, sir.
You're good. We're all you. You know, this is great, Joe. So then, since I made it in there, I can reject the ho. Good job, everybody. Support the hop. So this was just a statement of what we could do if Z star is less than this. Then we're so far away that it looks like it's wrong. All right, sweet, they made it way freaking far away. -3, that's 3 steps down. That's crazy far away. So that's really good evidence that the mean isn't 16.1. That is actually, it's really good evidence that it must actually be less than 16.1. Does that make sense? I mean, if the mean really was 16.1, our sample should have been really close. Was our sample really close? No, it's over 3 steps down. That's crazy evidence against it being 16.1. So I can reject the null, support the alternate. So, well, how do I write this? What was the claim? Which one, the ho or the ha? The ha. Here's the claim, and we put it here. So therefore, I'm going to use this language. So we succeeded. So we have found sufficient, good Lord, Jeff, evidence. It's a really bad writing day for me, which means it's a day that ends in Y. We have found sufficient evidence to support the claim that play drugs. Well, and here I'm just going to summarize even. The new drug works faster than the old drug. It's beautiful. That the new drug works faster than the old drug. So if we could, if this was a real thing we did, we could then make a commercial and say, it's been clinically shown that our new drug will give you relief quicker than this other one. And then more people will buy our stuff. Yay! We can maybe make even more profit off it. Yay! Ooh. Okay. Maybe. So let me do this. I'm going to give you the answer key. I'm going to see if there's any other specific ones you want to look at. See if there's any more specific questions. Sure. You can see the one we just did. Oh yeah, I forgot the p-value. So to get the p-value, you just look up -305. So you should get 0.0011. You can check me on that, maybe I'm wrong.
Do we multiply by 2?
Is this a two-tailed test?
Oh, you're right.
So that's a good question though. Yeah, you only have to multiply by 2. You only have to multiply by the number of tails. So if it's a one-tail test, you leave it alone. The two-tail test, you gotta double it. Yep. Let me try this. So look that over. Think about it. I'm gonna look up one thing to show you guys. But let me know if you have any specific things you wanna go over. Tools, give it to me, okay. Blah, blah, blah. Oh, shit. It's not good news. Let's see. Bless you. Oh, come on. Well, I guess I'll do this one. This is, all right, this is bad news. Let's see. Let's see what this one gives me. Come on, do it. Shoot. Why don't you give it to me? There it is. All right, here we go. Bad news for some of us. So this study showed there's an association between cannabis use disorder and schizophrenia in young males. Notice it says cannabis use disorder, so as long as you don't have a disorder, you're fine. But what I really want to show you is a couple things. They did the study. Here's the results. They looked at, holy shit, is that 6 million? Okay, whoa, okay, whoa, that's pretty good. I don't know what their number, they're a little bit freaky. Okay, so there's a few specific shit we don't know, but look, slightly higher among males, look here, 95% confidence interval, right? Than females. So whatever this thing measures, do you see how the men are higher than the women? But what's more important is the confidence intervals don't overlap. Do you guys see that? This one ends at 217, this one starts at 233, yes? Since they don't overlap, that is evidence they're not equal. That's actually evidence that men are higher. No pun intended. Blah, 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 blah. But eventually they finally get down to not just confidence intervals, they actually do hypothesis test. There's the p-value. This is stupid small. This is crazy. This right 0.0001. There's a 0.01% chance that the differences they saw was purely because the samples were weird. So what's more likely than that is there really is a difference between men and women. Do you guys see that? I mean, that's so. What you're going to see in the real world, there will be no alphas in the real world. They're just going to give us p-values. Because one person's good p-value is somebody else's bad. It's not enough. This, though, holy shit, that is really tiny. 0.0001. That's really freaking small. So that is good evidence that what they found is real. If the p-value was like 0.06, that's not really strong enough evidence. There's a 6% chance that what they saw was just because of random variations in the samples. 6% doesn't sound big, but it is kind of big in terms of showing really good proof. It's just not good proof. This, not proof, but evidence, this is really good evidence. Okay. Maybe. So I really want you guys to understand. There are technical medical things being said here. I don't understand what some of them are, but we can totally understand their analysis. You know confidence intervals. Now you know p-values. You can totally get what that's saying. I wish you could find another study. Let me see. Blah, 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 blah. Okay, let's see. Find another study. Everything's about marijuana. Let's see. Female astronauts more efficient. Okay. Give me the study, give me the study, give me the study. You're taking too long, go away. Okay. Give me the study, give me the study. Here it is. Okay. Good, sure. It's not my computer. Take all the cookies. Well, okay. So this one again. See the little p-values? Is that a good p-value? Is that showing good evidence? The p-value there? What do you guys think? Is that p-value big or small? Small. The smaller the p-value, the more likely it's true what I'm seeing. Right? There's a 0.1% chance that the differences they're seeing are just because of the way they pick their samples. Do you understand what I just said? There's a 0.1% chance that there isn't really a difference, that it's just the way they pick their samples. So what's more likely? That they did something that had a 0.1% chance of happening, or there actually is a difference? It's more likely that there is a difference. But again, there's a 0.1% chance they're wrong. I wish I had a 0.1% chance I was wrong in a lot of things that I do, but no. Okay, I'll go and stop. I don't care, CNN. All right, let's see. There's not a lot of studies here. Let's see. Barf. Go back to a month. Gosh, okay. Gosh, there's a lot of stuff about freaking marijuana. It's weird. That one doesn't tell me anything. Oh, here we go. This is interesting. Maybe it's just for me. Let's see. What you're always looking for is the actual study, but I don't see it here. Oh my God, that's just weird shit. Let's see. More marijuana. What's up with the marijuana? Okay, enough. I can't possibly. So I showed you a couple ones. So what you'll see in statistical analysis is the confidence intervals, but you will also see the p-value. The smaller the p-value, the more significant what they found is. That is the number one thing I want you to come away from with all this. Because that's what they're going to say. They're going to say the p-value. And that's their way of communicating, hey, we just found something crazy that kind of shows evidence. Look at this. Maybe? Okay. Anything else from that practice test you guys want to focus on? So remember, oh, sorry, go ahead.
For number 1B, why do you do 110 minus 32?
I'm sorry, this is totally the wrong thing. Oh shit, here it is. 1D?
1B.
1B.
Why do you?
Oh, so look at the question in 1B. And again, oh, sure. Maybe I should show you what I'm doing. How many students did we pick in the first place? 32, yes?
Yeah.
How many more students?
Oh, okay.
Yeah, now again, so what that means is, if you do the work, if you do the n equals thing,
Yeah.
I'm sorry, which one would this be? Was this,
Yeah.
yeah, this was this one. You're gonna get some number, that's the total number of students you need. You've already got 32, so you would subtract to see how many more you need. If you don't subtract, you just give me the number, I'm not gonna take points off. Right? I don't want that to be a trick question, but we already got 32. So if I need, what was it, 110?
Yeah.
Then you figure out how many more you need, yeah.
Got it.
I like it. I like it a lot. What does this mean on number 2, the first part of this? What does check for normality mean on number 2? What do I check?
It's normal.
Yeah, how do I check that on that problem?
Greater than 5.
What's greater than 5?
NP.
NP hat, NQ hat.
Yeah.
I like it. So I would first figure out what P hat is, and then you can do that, yeah. Okay. You guys look really beat up, so if you don't have any more questions, we can end early today if you want to. Or we can just sit here and look at each other. It's up to you. So are there any other questions, anything you want to go over? So if I ask you to construct a confidence interval, you know you're going to look at these 3. If it's a percentage problem, you know it's only this guy. That's it. That's the one you're going to use. If it's a mean problem, oh shit. Then it's all about, do I know the population standard deviation or do I not? That tells you which one of those to use, yes? The only time you're gonna use one of these three with a plus or minus is if I ask you to make a confidence interval. Don't try to throw these in somewhere. I always get somebody trying to throw these somewhere they don't belong. You know I'm gonna give you one like number 3, where you have to put this into your list and do 1-bar stats to figure out X bar and S, yes? You know I'm gonna do that. So make sure you know how to do that in the calculator. Make sure you can put that in and get the same numbers I got on the key. Yeah, we finished the bottom. Well, number 6, the type 1 and type 2 errors, right? So number 4, this will be related to this. So type 1 error would be that statement is true. So you would just say, for type 1 error, the mean really is at least 16.1, but we think it's less. So type 1 error is rejecting a true null. So you would say, this is true, the mean really is at least 16.1, but we think it's less than 16.1. That would be a mistake, right? That would mean we made an error. That doesn't mean we did anything wrong. That's just in real life, you can't ever really know everything. That's why I personally love statistics. It's the most honest math. Algebra, you're like, X equals 7. Yeah, I can always do this shit. No, stats is like, we're not sure. There's a chance we're wrong. Shit, sorry. I have no problem leaving if you guys are ready. I don't want you to feel like you have to sit there until I actually say go away, right? But if you guys are ready, we can head out. If you have any more questions, obviously, let me know. Don't forget your IDs, please, dear God.